So now we have covered all the basics of the height field erode node. Let's move on and finish creating the environment that we have in the final piece. So now we have our initial erode and our initial shape for the terrain. We can add some more detail to it by first dropping down a height field resample. And what this does is give a little bit more resolution to the height field. In this case, I'm going to give it 5 times more. You can see if we middle click that we now have 2 million voxels to play with. So one of the things that we have in our reference image that we don't have in this height field at the moment is some nice almost bulbous shapes that you get from rolling hills. So let me bring up the reference. So this is another Scottish landscape, and one of the obvious things that we get here are these bulbs, these kind of hills that poke out, and it's something I'd like to try and recreate and add into our landscape here. One way we can do this is using the height field layer node, or the height field distort by layer node. Just drop this in. Height field distort by layer. Here we go. Now we could add another layer in here if we wanted to blend the two and distort one by the other. But if we choose not to, then we can still add some really nice shapes just on its own. So add that in. And really, we want to do the opposite of what it is that it's doing at the moment. So we'll crank this up and change the rotation of the displacement to something like 60. I'll also turn on swirl and smear. So what the swirl does is it almost inverts the distortion, and smear kind of blurs it. So what we end up getting are these really nice bulbous shapes that feel like they're flowing down the mountain. At the moment they're a little ugly, but when we start to add some more erosions on top of this, you'll see that we get some really nice little rivers running in between. Okay. I'll add another height field distort just to get some more interesting shapes. And change some of these settings. It's a little strong. It's also a little big. And we can make it a little rougher too. That feels nice. Now we're starting to get some really interesting details, especially at the river's edge. And we can emphasize these with a couple more nodes. Before we add in our second erode node, I do want to re-emphasize this river just to make sure that it doesn't get lost when we recompute the erosion. So again, I'll just copy and paste this projection. Good. Now we have the river back. Now let's do another height field erode. This time we're going to notice some different details only because we have a higher resolution to work with. So tab in erode. You'll also notice that we have 4 in total different nodes that we can use to erode the height field. Now, the height field erode is just a combination of these 3 guys with some extra functionality. But if you did want to do them separately, you can. Now, let's drop down the erode. Plug it in. At the moment I'm at frame 8, so of course it's going to try and calculate this up until frame 8. If we hit escape, we can cancel it. Go back to frame 1. And now we can change some settings. So first, I will, oops, didn't mean that. I will recompute this range. And we will put the erodibility to 5, just to boost it up a little bit. And that's just to give us some more rivers. I want to boost up the erosion rate, and again, it's similar to the erodibility, it's just a multiplier that goes on top. In the advanced tab, let's go to the max debris depth on the thermal erosion. Where is it? Here we go. I'll crank this up to 20 just to try and keep some of the debris from travelling too far down, and so it stays on the slopes of the mountains a little bit more. I'll increase the precipitation to try and deepen some of those channels, and reduce the density to try and make more of those little channels too. I don't want any big rivers here, I just want some nice little rivers, thin ones that are running through the mountains. Okay, now I'll just let this play. It is doing a much better job now of keeping the river where it needs to be, and I'm pretty sure that that's because we're working in Houdini 18. In 17.5 it did really smooth off any rivers that were carved in. And one thing I want to make sure that I have switched on is the spread iteration set at 0 and the post smooth on the debris flow. So let's freeze this at frame 15 maybe. Yep, this looks good. So now that I can see some of the shapes that are being created, I think I will adjust the camera a little bit. Unlock this. Move over a little bit, just so we can see some of the river a bit clearer. Maybe pull back some. Yeah, that's better. Just lock this again. And jump back inside. Okay, next. Again, if necessary, I could go ahead and reproject the details back in, like the river, if I wasn't getting the shapes that I wanted just yet after the height field erode. But for the moment, we're fine to move on. I'll drop down another distort. Some of these shapes, especially in the middle, are becoming a little bit too uniform for me. It's a bit nicer, maybe a bit strong. Oh, 5's probably fine. And again, the element size is a bit little big, so let's take this down. Oh, that's a bit small. This just breaks up the river some. A bit better. So I do like a lot of the shapes that are being created, but there's probably maybe too many details in certain areas. And to correct this, we can use the height field slump node. What that does is it adds a little bit more sediment layer to some of the slopes, and you can define this by an angle. So if we drop this in, plug this in, change the repose angle, set it to 5. And set the height factor to 0.5. One thing you'll notice is it won't actually do anything, and that's only because what it wants to do is work on a mask. And we don't have a mask, so let's create a mask. We will use the height field mask by feature. Mask by feature, drop this in. So I want it to only affect angles between 44 degrees and 0 degrees, which will invert this mask. And by height, we want it to work below 0, just to make sure we reach right down to the riverbed, and right up until, say, let's say 100. One thing you'll also notice is this is a really good way to generate masks that we can later use in texturing. So when we get to the shading part of the tutorial, we will blend a lot of these textures together using these masks. Anyway, if we jump to the height field slump, you'll see it actually does start to work on those areas. The two main functions of the slump node are the height factor, which dictates how deep this goes, and the repose angle, which starts to sharpen up some of these areas and change the direction. It doesn't need to go that high, I don't need it to be so strong. Flow fields I haven't used only because I haven't found a use for them. Again, I don't want this to be a tutorial where I just mention what they outline here in the information boxes. So I'll be honest, if I haven't used one, then I'll let you know. So as you can see here, as I play around with these settings, nothing is changing. And to be honest, I haven't really found a use for it yet. I'm sure there is one. And finally, we have layer bindings where we can again dictate what the input layers are and what the output layers are. So the slump node does generate these two new attributes and masks that we can use later, flow and flow direction. Once again, I'll put down a mask clear just to get rid of all this information that we're overwhelmed with almost in the viewport. And I would say that is us almost done generating the terrain. To make this usable though, we need to convert it to geometry. So let's drop down a convert height field. And I don't need all the density, at least not for now, so we can drop this to 0.5 and plug this in. I'll switch to smooth shaded just so we can lose the wireframe. And this is pretty cool, but to be honest, I probably want some more detail than this. Boost this up. Now, as this is a volume, one thing we could do is drop down a volume VOP node to do some more procedures to change some of the shapes and add some more interesting details. But since we have converted it to geometry, let's instead just use the attribute VOPs. Okay, so throw down an attribute VOP. And jump inside. If you are unfamiliar with the attribute VOP, on the left side here, we have the information that we can use. We have the position and the velocity. the color, the UV, and the normal. We also have the point number, the primitive number, vertex number, number of points, number of primitive, and number of vertices. We do have age, life, and ID, but for the purposes of manipulating what we have here, we won't need to cover those. So the first thing I want to do is make these rivers that we created in the erode generation a little bit more strong and a little bit deeper. And we have two ways of doing this. We have both the water attribute that was created that we looked at a little ways back, and we also have the sediment attribute that was also generated in the erode node. So if we just want, for instance, to cover a little bit more of the background of the attribute VOP node, if we just want the position that we have at the moment to match the position at the end of this, we would just plug P into P. And what we are saying there is the P position that we already have is the P position that we want in the end. This is a vector, so this covers X, Y, and Z. If we would like to manipulate this, we could, for instance, just add a constant. Add constant. Now you'll see it will start to move, and what this is doing is adding a value of 1 to each axis. So it will move by 1 in the X, the Y, and the Z axis. Obviously, we do not want this to happen. We just want to affect the Y axis. So we can take this vector and only affect the Y axis by dropping down a vector to float. This node splits this vector into 3 float values, 1 for each axis. So plug this in. But of course, we need to make sure we change it back into a vector so we can recreate what we need to achieve this P position attribute. So we create another node, but this time it's a float to vector. Float to vector. And we plug these back in. Again, we should see no change, apart from the fact that it's disappeared from the viewport. Okay, so I am an idiot, and I have unfortunately plugged in the velocity rather than the position, so let's change that. I should have noticed. Okay, so as you can see, there's no change. God. Okay. But what we want to do is affect just the Y value. So in this case, we will add a constant of 1 to the Y and plug that back into the Y. If I ramp this up by middle clicking, scrolling up to the 1 and dragging this up, you can see it begins to move in just the Y axis. Again, we don't want it to move the whole thing. We only want it to move where we have this sediment mask or this water mask, and we want it to move down. So we will bring in the sediment mask. There are a few ways to do this, but we will just import this point attribute. Now we can pick which type of attribute it is. It is indeed a vector 3. We are bringing it in from the first input dictated by this guy here. And we want the sediment value. Sediment. Awesome. Okay, so to manipulate this, we want to move everything down. So we have the add constant, and on this we will change it to, let's say, -2, which moves it down by quite a lot. I will then use a mix node, take the the output from the Y, the output from this value, which is the updated Y position, and mix it by the sediment value and plug it back in. So now you can see only the areas that are masked by the sediment attribute that we brought in are being moved down. And we can dictate how deep they go by using this value here. That's probably a little much, as you can see. So yeah, you can see we're getting a lot of nice information running down here. And again, this is a mask, so we can use this within the texture. Awesome. Now, one thing that you might be thinking is we are getting a lot of ugly shapes on these flatter areas, and that's fine. We are going to fill them in later using masks within the shader and displacement maps.